For our last chapter, we are going to revisit quadratic equations. We've talked about these before briefly. When we were learning about factoring, we talked about quadratic trinomials and different methods for factoring those. And then we talked about solving a quadratic equation by factoring. Well, unfortunately, not all quadratic trinomials are going to be factorable. So when you have a quadratic equation, you can solve by factoring, assuming that the quadratic itself is factorable. But what about the rest of the quadratics out there? What about the ones that cannot be factored? Either they can't be factored easily over integers or they just can't be factored at all. So we need to find new ways to solve these quadratics. So that's what the focus of this chapter is going to be, alternate ways to solve quadratic equations, okay? So let's talk again, just remind ourselves, what is a quadratic equation? Well, a quadratic equation is an equation that can be written in standard form as ax squared plus bx plus c equals 0, where a, b, and c are real numbers such that a is not equal to 0. So a, b, and c can be anything. They can be any integer, fraction, decimal, whatever you have, except a can be anything but 0. If a is 0, your squared term just becomes 0, and then you no longer have a quadratic equation. What makes an equation quadratic is the fact that it's a degree 2 polynomial, okay? Now we need to remind ourselves of square roots because in this worksheet, we're going to talk specifically about the square root method for solving quadratic equations. And so that's going to be the focus of, this video. And then we're going to have a couple of videos where we talk about applications to the square root method. Okay, so let's get started with the idea of what is a square root. We've talked about this a ton in the previous chapter, but remember, the informal definition of a square root is that it is one of two identical factors of a number. Okay, now the reverse operation of squaring a number is finding the square root of that number. Okay, similarly, the reverse operation of finding a square root is squaring that number. We need to know these things because they're going to help us understand how this property works. Okay, so for our first topic, we're going to just talk about the actual square root property. So we first need to consider something like x squared equals 16. Okay, so when we're looking at an equation like x squared equals 16, it's definitely a quadratic equation, okay? And our goal is to find the value or values for x that when squared, the result is 16. So let's think about that. If I take 4, then if I take x and square it, that just equals 4 squared, which is 16. So we would easily say, hey, the solution to this equation is 4. But is that every real number that when squared, we get 16? Well, no, there's another one. What if x is negative 4? Well, then x squared would equal negative 4 squared, and it just so happens negative 4 squared is also 16. Okay, so in this situation, we have two values that give us the same result. So we have two values for x that when we square it, we get that result of 16. Okay, therefore, we would say x equals the square root of 16 equals 4, but also x equals negative square root 16, which is negative 4. And so shorthand, we would say x equals the square root of 16, which equals plus or minus 4. Now, just for the sake of playing around, let's think about this another way. What if we had x squared equals 16? And we were like, okay, let's subtract 16 from both sides. That's great. We get x squared minus 16 equals 0. Okay, we learned how to deal with this back in a previous chapter when we were talking about factoring. We should recognize this is the difference of perfect squares. X squared is a perfect square, 16 is a perfect square. So I could factor this as x plus 4, x minus 4 equals 0. I could then apply the zero product property, which tells me that x minus 4 is 0 and x plus 4 is 0. And when I solve those individually, I get x equals 4 and x equals negative 4. So we've kind of gone this background route of setting this equation equal to 0, putting it in standard form, factoring it, and solving it. And we do get that x squared equals 16 means that x is 4 and x is negative 4. But we don't necessarily always want to do this factoring method because sometimes we're going to get values where factoring and the difference of squares isn't going to be the case. So that's why the square root property is so powerful, okay? So let's look at the actual square root property. So the square root property says if u is an algebraic equation and d is a positive real number, then u squared equals d has exactly two solutions. U equals the square root of d, or u equals minus the square root of d. Equivalently, if u squared equals d, then u equals plus or minus d squared. That's basically saying the exact same thing that we said before, except replace x with u and replace d with 16, and you get the same answer. Okay, so here's what we're going to do for the square root property. Hopefully when you see it in practice, it'll kind of click a little bit more. We want to isolate the expression containing the squared term or the squared variable, okay? So you want to isolate whatever term has the squared component to it, okay? You then apply the square root property, which just means take the square root of both sides. We basically want to get the variable alone. And if we have an x squared component, we need to undo that x squared. The way we undo a squared component or a squared variable is to take its square root, okay? Isolate the variable if necessary. Sometimes when you isolate the squared component, you haven't isolated the variable itself. So once you do the square root property, you may have to isolate the variable again and then verify your solutions. So let's see what we've got here. Example 1 says solve by the square root property. Well, for part A, we have x squared equals 36. The first part's already done. We've already got the variable term, the squared component isolated. So we need to undo the squared part. How do we undo squaring something? Well, we take the square root of that. So we're going to take the square root of both sides. But you have to remember, we don't know what x is, but we do know that no matter what x is, when we square it, we're going to get positive 36. And whether you're squaring a positive or you're squaring a negative, when you square it, you get a positive result. So we have to remember to put a plus or minus over here. Okay? Again, we don't know what x is. We just know that no matter what, if it's positive or if it's negative, when we square it, we're going to get a positive value. Okay? So the square root of x squared is just x. That's easy. And then we get plus or minus the square root of 36. Well, the square root of 36 is just 6. That's one of two identical factors of 36. So we would say the solutions here are x equals positive 6 and negative 6. These two things are the same. This is just kind of like shorthand. So just make sure you understand when we have plus or minus, make sure you understand what that means. Now let's check the solutions. Let's check x equals negative 6 first. Well, anywhere I see an x, I want to replace it with a negative 6. So I have negative 6 squared. We want to know, does that equal 36? Well, it does. Negative 6 squared is 36. So that one works. We also want to check x equals positive 6. So anywhere I see an x, I'm going to replace it with a 6. So I get 6 squared is 36, and 6 squared is 36. So we can say with confidence our two solutions are negative 6 and 6. And there you have it. Okay, I don't want to say it's that simple, but it is that simple. You just have to really get to the heart and soul of what this property really says. When you take a number and square it, that number can be positive or negative to begin with, but when you square it, it becomes that positive. So that's where we get these two hidden solutions, or not really hidden, but we get these two solutions. All right, for part B, we have x squared minus 24 equals 0. We want to isolate the variable piece that is squared. So we want to isolate x squared here. To do that, we want to add 24 to both sides. Well, negative 24 plus 24 is 0. So that leaves me just x squared on the left. And then on the right, we have 24. So the squared part has been isolated. To undo the squared component, we take the square root. So we're going to take the square root of both sides, and don't forget your plus or minus. Remember, we don't know what x is. All we know is that whether it's positive or negative, when we square it, we're going to get that positive 24. So we have to take into account that x can be positive and it can be negative here. So the square root of x squared is just x. Now, when it comes to the square root of 24, we need to simplify this radical, okay? So I happen to know that 24 is the same as 4 times 6. Now, 4 is a perfect square. So what is the square root of 4? Well, it's 2. So we get x equals plus or minus 2 square root 6. Okay, now let's check it. So let's check negative 2 square root 6. So anywhere I see an x, I'm going to plug in negative 2 square root 6. So I've got negative 2 square root 6 squared minus 24. Hopefully that is 0. Okay. Now, basically what's happening here with negative 2 square root 6 is we have a product raised to a power. So we can bring this exponent of 2 into each factor of this product. We technically have negative 2 times the square root of 6. So we can think of it as those two components. So I get negative 2 squared, square root of 6 squared. Well, negative 2 squared is 4, okay? The square root of 6 squared, when you square a square root, they just undo each other. So that just equals 6. Well, 4 times 6 is 24. And 24 minus 24 really is 0. Now let's do the same thing, but this time we're going to check positive 2 square root 6. So I get 2 square root 6 squared minus 24 is 0. Well, 2 square root 6 squared, we're just going to think of that as 2 squared, and then the square root of 6 squared. Well, 2 squared is 4. Square root of 6 squared is 6. And 4 times 6 is 24, and 24 minus 24 really is 0. So we would say here our solution is negative 2 square root 6, positive 2 square root 6. So this example right here is why we can't always do that difference of squares thing. Like up here, I wanted to prove to you that this property really did work. So this is kind of our proof. Okay, we could do this because when we moved 16 over to the left and we had a quadratic in standard form, we were able to factor it. Okay, we couldn't do that down here. Down here for part B, we didn't have the difference of squares. So that's why this property is so nice. It allows you to solve things that don't necessarily become the difference of squares. All right, let's look at part C. So same directions, we just want to solve and check our solutions. All right, first thing I want to do here is isolate the negative 2x squared. So that means I'm going to move the 100. So let's move the 100 by subtracting it. Well, that gives me negative 2x squared equals negative 100. 100 minus 100 is just 0, leaving that negative 2x squared on the left. Now, I don't like the fact that I have a coefficient on x, so let's go ahead and move it. Let's isolate x squared all by itself. So we're going to divide both sides by negative 2. Well, negative 2 divided by itself is 1. 1 times x squared is x squared. And then negative 100 divided by 2 is positive 50. So now I have this variable component in a term squared. I've isolated it. So now we take the square root of both sides. And don't forget, I didn't leave enough room here. Let me rewrite that. Don't forget your plus or minus. Well, the square root of x squared is just x, okay? And then we get plus or minus. Now, the square root of 50, I happen to know this could be rewritten as the square root of 25 times 2. And the square root of 25 is just, it's a perfect square, so that's just 5. So this equals plus or minus 5 square root of 2. And I'm not going to take the time to solve, like to check my solutions on this one because it's going to be the same exact process as part B. But you do want to check x equals negative 5 square root 2. So we would get negative 2 times negative 5 square root 2 squared plus 100 equals 0. And I'm just going to go ahead and say we get negative 100 plus 100 equals 0. So that one works. And then we're going to check x equals 5 square root 2. That's supposed to just be a 0. So we get negative 100 plus 100 equals 0. Everything checks out, and we would say our final answer is negative 5 square root 2. 5 square root 2. Okay, so if you want to go back and like officially check your solution, pause the video, go back and just double check that negative and positive 5 square root of 2 plugs in and you get a true statement. Okay, finally for part D, we have x minus 5 quantity squared minus 20 equals negative 4. Now, what's a little bit different in this case is we're not going to be able to isolate a single variable squared. So we need to take this x minus 5 quantity squared and isolate that whole thing first. Okay, so the issue here is just the plus 20. If I tried to FOIL out x minus 5 squared, I would end up with two terms containing a variable and it'd become complicated. So this is actually the format you want. Okay, you want it to be either a single variable squared or a a single term containing a variable squared. So that's what we have here. So we want to isolate the entire x minus 5 squared. We're going to add 20 to both sides to do that. So on the left, negative 20 plus 20 is 0, which leaves me x minus 5, excuse me, squared equals 16. And now at this point, we have the variable in a term squared. Okay, even though it's not the single variable all by itself, we can still proceed at this point. So we want to take the square root of both sides. Don't forget your plus or minus. And then when I take the square root of x minus 5 quantity squared, the exponent of 2 and the square root just undo each other, and I'm left with just x minus 5 equals plus or minus 16, which the square root of 16 is, or plus or minus the square root of 16, and the square root of 16 is 4. Okay, so do you remember up here I said isolate the variable again right here if necessary. This part D is a situation where you isolate the variable expression squared, and then you isolate the variable again. So down here, we want to get x all by itself. So to do that, I need to add 5. And when I add 5 on the right, I want to put it in front of the plus or minus. Okay, so on the left, negative 5 plus 5 is just 0. X plus 0 is just x. And then plus or minus 4 plus 5, I want to put the 5 in front of the plus or minus, so I'm going to think of this as 5 plus or minus 4. I just think that's a more typical way to write this. So put the whatever you're adding or subtracting from both sides in front of your plus or minus, and then don't stop here. You've got a little bit of work left, okay? So x equals 5 minus 4 and x equals 5 plus 4. You have to take into account that plus or minus, okay? So 5 minus 4 tells me that x is 1, and then 5 plus 4 tells me that x is also 9. So let's go ahead and check these solutions, okay? So we want to check x is 1. So anywhere in this equation I see a 1, I'm going to replace, or anywhere I see an x, I'm going to replace it with a 1. So I've got 1 minus 5 quantity squared minus 20 is negative 4. Well, inside parentheses, 1 minus 5 is negative 4. So I get negative 4 squared minus 20 is negative 4. Well, negative 4 squared is just 16. And 16 minus 20 really is negative 4. So this side works out. Let's also check x equals 9. So anywhere I see an x, I'm going to replace it with a 9. So I get 9 minus 5 squared minus 20 is negative 4. Well, 9 minus 5 is 4. 4 squared minus 20 is negative 4. Well, 4 squared is 16. And 16 minus 20 is negative 4. So everything really truly does check out. And I want to say my solutions here are 1 and 9. So that's the square root property. It's a very powerful thing. In the next worksheet, we're going to talk about this method for solving quadratics called completing the square. And our whole purpose is to create something like this. Okay, we're going to create something where we can take the square root property and apply it. Okay, so this is a really important method. Make sure you understand the square root property.